Second presentation of this session is by Johanna Hansen from Posiva, who's going to talk to us about the DOPAS project. Lots of pictures of seals, I think. So this was a project that's run for a period of 4 or 5 years, some fairly major construction of tunnel plugs and shaft seal demonstrations. So, Johanna, thank you.
Thank you, Chair. Dear EURADWASTE audience, I have an honor to tell you about tunnel plugs and seals. It's a collaborative project which was implemented as part of the 7th framework program during 2012 and 2016. So now it's a good opportunity to look back a couple of years ago, like to the project which already has been ended. And also, I don't have any responsibilities against the European Commission any longer within this project, so it's all sort of like released to be here and tell a little bit about the, like what was done within the DOPAS project. So I'm looking a bit of the background, but then of course I'm trying to inform very shortly what was done within the DOPAS project, what were the main findings and what were the main lessons learned. And also I think that it's really interesting for you to hear what, how our experiments, what are their status still today. And I'm trying to, since this project is already ended, so I'm trying to look at from the 2 different point of views. Also, firstly from the technical point of view, but then also from the project management point of view, as there are certain things which were really successful in DOPAS, and I think it will help all of you who are working with the Horizon 2020 and within the EURAD project now. So there are some things that maybe hints for you for your success projects. So already more than 8 years ago, there was the IGDTP's SRA and the vision for the 2025, which we did hear yesterday about more, but sort of that was also found within the VMOs that there is a common need and joint challenges, while plugs and seals are needed for every program and for every concept and for every host rock. So there are a lot of joint aspects what can be done jointly, and as I think it was also supported by the EC that that's an important task what we can really do jointly and together. And also to be able to reach the Vision 2025, it was said that the top priority is the needs for the organization, the VMOs who are nearby the licensing and the implementation phase. So therefore, the type of the project was targeted for the demonstrators, but don't even think about that to construct a demonstrator is easy. It requires a lot of work, a lot of background work, and therefore within the DOPAS, so the work was divided in the different parts, and I will show soon how it was. But basically, the open questions were that. What type of design basis and the constraints that does exist in the different type of host rock environments? How does the plug location should be sited, and what type of information is needed? What are the practical installation and related to the monitoring, and how to we ensure that after installation we know whether the specifications and the requirements were fulfilled. So that was one important part of the DOPAS demonstrators. For you who are not so familiar with the tunnel plugs and seals or the different type of plugs and seals, so here is an example picture from Posiva, and it just shows that there are several type of the plugs and in several locations in the future repositories. So as main point we can say that the plugs might be rigid concrete structures with mechanically supports, for example, the backfill materials. Then there are situations where there are groundwater inflows into nearby the repositories, so the plugs are used to separate different areas from each other, or then during the operating period they are like separating the operational area and closed area from each other. So for example, at Posiva case, we do have around 100 deposition tunnels, so we do need the 100 deposition tunnel plugs as well, which means that during our operating period we have to construct 1 or 2 plugs for each year, which means that it requires a lot of also like the knowledge behind how to do it efficiently during the operating phase. I think the same is for SKB and for basically for ANDRA and for many organizations who are still considering and planning the repositories. Then about the DOPAS project, so it was the consortium did consist from 14 beneficiaries from 8 European countries, and they were representing VMOs, TSOs and the REs. And in addition, there were a lot of other organizations doing the work for the DOPAS. Since we had quite the budget for the easy support was 8.7 million euros. So altogether at the DOPAS, like the whole bunch of the money to make those demonstrators was much larger. So it was a question of almost 25 million euros, and an extensive part of the work was still conducted outside the European support, but still it was reported as part of the project. And in the presentation, so you see the name of the organizations in the handouts or in the footnote. So but now it will not. Now all the organizations is not seeing there, but in your app, so you may see them. So the DOPAS was organized in the following way. So we had the 7 work packages, and it was as a matrix, as we had the demonstrators. So they are in the columns there, and then it went throughout, so like all thing was done in the integrated way, in that way that we had the work package leaders and we had the experiment leaders. The experiment leaders was working together and looking the different tasks like design basis for like practical aspects for the implementation, for the material studies, and all of them were like then handled in those both demonstrating and R&D work packages, and then compiled together for summary reports. I have the links to reports later in the presentation. What were the main objectives for the DOPAS project? So the objectives were to create the design basis. Objectives was to develop reference designs for the plugs and seals. It was also to make an like more very detailed design basis with comprehensive information from all viewpoints to be able to construct the demonstrator. In addition, there was like the construction of the demonstrators and the huge amount of the laboratory and metric scale studies behind. Then there was also like the assessment of the monitoring of the experiments, and also how to use the experiments for the safety case work in continuation. And also, of course, as in all other projects, so important part was also the dissemination and way of making the summary reports and the way of making like the review of those and staff exchange between the different organizations in that way that was really useful for organizations to visit in other organizations exactly when they're doing the work and to report and ask questions and make criticism and collect the information, which was then handled jointly in the project. Yeah, that is, I added some nice pictures for you in the presentation about like how is it when doing the full scale. We have actually a couple of videos about the experiments for ANDRA, for FSS experiment for ANDRA. So there is a video available at the DOPAS website, and also for the POSIVA's plug experiment there is a video available. And then if you consider why the demonstrators are needed, why it's important to make things in the full scale. So that is a good question, and I'm really, and I think all parties who were involved in the DOPAS does consider that it's really important to make the things in the different scales. The one thing, of course, when you make it full scale, so in that way you may increase the confidence when you show that you can reach the target, you have a plan and you can implement the things according to the plan and you can analyze and follow and see what happens then afterwards. That is one thing. Another thing is that the processes might be different. You don't see all the things in a small scale, in the laboratory scale. There are need for the full scale to see the things in a proper in another way, and of course like the training for the operating period, but also to be able to see what type of documentation needs, quality assurance, quality control needs, and all those aspects are really important, and they can be seen only when doing the things in the full scale. The fact is that behind your desk, all the things are much more simple than they are in the real world. And of course, within the DOPAS, when we are talking about the plugs and seals, so we will hear later today and tomorrow as well, so a little bit about the ongoing EASY projects, ongoing joint European work related to the both concrete and the bentonite topic. So of course the concrete and the bentonite were the main materials, and then most of the experiments, they were monitored, and we will hear about the monitoring later today as well. So in that way that within the DOPAS, so it was like collected, all the information did exist, and now of course our duty was to provide all the things further, but still I think that it's as already like 3 years after ending a project, I noticed, and I know that my colleagues noticed, that a lot of things has been forgotten already now. So it's really important to continue the discussions and sort of to ask in the current projects that what happened in the past. So there are a lot of things what you can really learn and use for the future work as well. And there was a lot of things what was discussed within the DOPAS, whether it's good to make the experiments like in the below surface conditions, in the real conditions, or then in the artificial tunnels above the surface. and it was found out that the boat has their sights to make the experiments above surface. So that's sort of easy. You may have windows in your tunnel and look really like how it happened. Below the surface, you don't have that aspect, but then below the surface, when you are doing it in real conditions, where the rough walls and the rough floors and so on, so you learn much more about the practicalities, and that's useful to do, as I said, in the different scale and different locations to make a different type of experiments. That's always useful, if you remember also to collect all the information and share it with your colleagues. So pretty much I also sort of this text there behind, so are the things which I already tried to explain in a little bit more practical way, and I'm sure that I don't have so much time, so I jump a bit further. But in the way where in DOPAS, so we were working together, so there was actually I think like we were like around 10 to 20 or even more persons in each participating organizations. So it was really good way of doing the benchmarking for the other organizations when the information was shared. And also what are the things which related to the risk management and the quality assurance, and those so are really good to do in the different type of the locations and different type of the experiments, while our experiments, they still were representing like all European like host rock environments, both the crystalline clay and the salt rock. So it was good to see that what things are relevant for different type of host rock environments. Here is the list what the DOPAS will or has been already provided further for the future generations, and the one thing what was really nice was that there was like the three of the organizations were quite near of the implementation phase, or were in the licensing, nearby the licensing phase, and then there were organizations who were sort of like more in the beginning of their like the planning of the repositories. So still it was found out that those demonstrators were useful for all different organizations and not only for the most advanced ones. And it was, yeah, the design basis was really important. Then it was interesting to note that when doing the design for this type of specific components, so and that same applies for all EBS components in the repository, not only for the plugs and seals. So the thing is that you need to involve also like the construction people in the design and in the planning phase. And the also other thing is that when you are implementing and doing the practical demonstrators, so you need to have the people from the design part. You need to have them on site and to be able to see that is there are there needs to make changes, are there needs to update the design, and one thing is for sure, it's better to make some demonstrators and tests before go into the real repository. That's I think is obvious for all of you, but it's still good to remind. Then if you look like a few of the experiments, this and now when it's said here that the FSS full scale seal. demonstrated by Andra in Saint-Dizier. So there were other organizations as well participating, not Andra alone, and that's important. That's the same for the all experiments. So there were a bunch of the organizations doing the work, but the names here are the responsible organizations. So that was a hamburger type seal structure with two heavy concrete blocks and bentonite seal and bentonite core there. So it was, of course, due to the size and to the time limits and frames, so it was impossible to see the saturation of the bentonite. So in addition to the FSS test, there was a REM, the bentonite resaturation test, which role was to see how the similar materials used for similar bentonite used for the seal core, how it is used in the metric scale. So this setup is around the size of the 850 liters, and as you see here, so it was used to support the results from FSS experiment. It's still ongoing in Bure, and it's around soon. Around 4 years it has been running, and there are like still like inflow into the chamber, and as you can see now that there are like the more blue one areas are more wetted one, and the yellow ones are more dry ones. So it seems that now after 55 liters, so it's partly wetted, but it takes double that much time what was expected to be get the full saturation. So basically those type of mock-up or in situ experiments are also then important to be able to have like the results which and those can be then used for the safety case work, and even it takes a long time until the total saturation is reached. So the information received already within the short time of period shows whether the models are correct, or shows that in that way that the evolution goes to the right direction. Then the second of the experiments EPSP, so experimental pressure and swelling plug, conducted in Josef Gallery by the Czech participants. So that was also there was two different type of concrete structures, and there was also the bentonite core, and it shows that after 4 years, so the swelling pressures are like the total pressure is like slightly increasing, but already now after 4 years, so the pore pressures has been started to increase, and now at least the situation is that experiment will be followed still a couple of years before the dismantling, but it will be then dismantled in the future. Then we have the Swedes test, or there was two deposition tunnel end blocks variants. One was conducted at SPÖ laboratory by SKB in charge, and that was the dome type of the plug, and the second one was the wedge type of the plug, which was conducted by Posiva in charge in the Onkalo facility. And there the dome plug, so it was monitored for the several years, and there was all the time, so it was used like artificial pressure, which is the same as the pressure in the repositories at the depth of below 400 meters in the crystalline host rock. And And basically, it can be said that even in that pressure condition, so the leakages were quite moderate. Thereafter, it was tested about for the gas tightness, the plug itself, and the plug was consisted from the concrete part and from the bentonite seal part. So it shows that the bentonite seal works really well, while the plug seemed to be totally gas tight. And during the last year, so it was like according to the original plans, but we didn't have the time to do it within the DOPAS time frame, so it was done now a little bit afterwards. So that plug was pressurized with sort of a higher pressure than planned. So it was 10 megapascal was fed into the plug and looked at whether the plug may resist it, and it did resist it, yeah, very well. And thereafter, the plug was dismantled and sampled, and there are like some information available at the SKB's homepage about it as well. Then was the Posiva plug, Poplu, which was a wedge-type plug without the seal layer behind. So it was constructed and it's still there. We actually, Posiva had to remove the monitoring system while the excavation work in the tunnel was continued, and there was the risk that the monitoring will not survive the excavation work. So for the temporary, it's sort of like being there in the natural conditions, and in the future. So we will check how it looks then, but then as Posiva made after to making the single component tests, so Posiva did test the whole disposal concept in the full scale, in this full scale in situ system test. So we made a comparison between both the wedge type and the dome type of the plug, and both of them could have been feasible, but when we had already the experiences to construct the wedge type plug, so we wanted to construct a dome type plug with the seal layer as well, and there were some other aspects related to the amount of the materials and so on. So now we have experiences to make two different type of the plugs. And here are just the pictures from the construction phase, and actually now they are like dismantling the formwork. So from that. So I know that I should quit now, but just like a few words about the foreground and the dissemination. So DOPAS did arranged like one training school in Josef Gallery and in Prague, 2015, no, 16. Now it's already so long time ago, I don't even remember the year, but that was a good opportunity to young researchers to be there, and thereafter there was the DOPAS final seminar, and also like DOPAS did publish almost 100 deliverables, and almost all of them, all public ones are available on the DOPAS website. But what I would like to show the numbers of the main report. So in case you are interested to hear more about the design basis for the plugs and seals, about the practical aspects for the implementation, or for the how they have been monitored, and what the plugs has been served towards to the safety casework. So these 5 deliverables are worth of seeing and reading. Yes, otherwise I have to say that it was a really good project to coordinate, while I had so good and nice team to work for the demonstrators and experiments. So, thank you for your attention.